Greetings and welcome to a class in quantitative methods. In this series of sessions, we will be discussing statistics for managers. This is an exciting journey, and for any manager, we promise to keep it as simple as possible. So welcome again. So why should managers bother about statistics? There is an exponential growth of data, and with decreasing costs, there is an explosion of data which is accessible to all managers. This overload of data would overwhelm any manager. By organizing and summarizing, data can be transformed into knowledge that will enable decision making. Management needs a snapshot trend in the volume of work to justify requests for more personnel. If a manager requires extra resources, he needs to establish an upward trend in the volume of work. Regarding customer complaints, if we bucket the complaints correctly, we may find that the 20-80 rule may apply. That is, 80% of the problems may come from 20% of the causes. Focusing on these 20% causes may do wonders for the business. Similarly, to estimate the probability that a customer may miss his premiums, the insurance company needs to identify the criteria that helps classify the riskiness of a client. Since testing the entire consignment may be impossible, the manufacturer may need to take a sample and test the sample to see whether the consignment meets the customer's specifications. Of course, the starting point is data. An ice cream manufacturer intent on introducing a new exotic flavor will want to estimate the size of the market. There may be several variables of interest, such as how receptive the target market is to exotic flavors, and perhaps the per capita expenditure on sweets, ice creams, etc. Some of this data may be bought, accessed from industry databases and market research firms. Such data are called secondary data. If the company is already operating in the target market, it may decide to study its existing customers to estimate the market. Such an exercise would be called getting primary data. The company could do an experimental study by doing a taste test for a sample of its customers or potential customers. Or it could do an observational study by asking questions of its customers. Once we have the data, the first step is to summarize the data. Numerical measures such as mean, median, mode are measures of central tendencies. Each is a statistic which we hope is typical of the population. Notice that if we are summarizing a sample data, the summary statistics are represented by Roman letters. If we are summarizing population parameters, these parameters are represented by Greek letters. There are other numerical measures such as range, variance, standard deviation, interquartile range that give the manager an idea of how the data is spread out. We could also use tabular representation of the data. So things like frequency distribution, relative frequency distribution, cumulative frequency distribution. In the picture out here, we have the location of customers. This table gives us the spread of the customers across the 4 zones: east, north, south, and west. The second column gives us the frequency of the customers. The third column gives us the cumulative frequency. And the fourth gives us the relative frequency. So these are tabular representation of the data. Finally, graphical representation may be used to describe the data. Artifacts such as pie chart, bar chart, histogram, and trend lines may be used to represent the data. Sometimes it's impossible to access the population. For example, the target population of a restaurant comprises existing and also potential clients. If the manager wanted to do a survey, she could never do a census. so she could only sample. Once we have a good grip on the data, we could then ask, can the measures of central tendencies and dispersion be representative of the population? The restaurant will want to know how happy his customers are. Since it's impossible to take a census, he could approach randomly selected patrons and ask them to rate the service on a scale 1 to 5. The average would be a statistic. If he believes the sample from where he got the data is indeed representative of the population, he could then extrapolate this statistic as a parameter for the population. This exercise would be called an estimation. We could also test some hypotheses about a parameter of the population. Suppose during appraisal time, the manager claims that the average rating is 4 out of 5 for his restaurant. The management could then take a random sample of clients and test whether this is true or not. Such an exercise is called hypothesis testing. So both estimation and hypothesis testing comes under the title inferential statistics. In the coming sessions, we will focus on summarizing data to generate information and going beyond this information to generate knowledge by making estimates and predictions and also testing hypotheses of the population. In the sessions, we will not focus on collection of data. The organization of the sessions to follow, we will first focus on descriptive statistics. We will then follow this up with probability distributions. After this, we will take estimation and then discuss hypothesis testing. And finally, we will do simple linear regression. Today, we have discussed descriptive and inferential statistics, sources of data, what are observational and experimental studies, a variable is a characteristic of interest, population and sample, parameter and statistic. Thank you.